Okay, last time we added intervals up to a seventh after defining what strong and weak intervals were. Here are some of the examples we covered. Always feel free to pause if you need more time. We also dealt with negative intervals, as in the examples here. Pause if necessary to review. Let's first notice a couple things about intervals adding to an eighth, an octave. As usual, the normal rules for addition still apply. But how do we know we have to modify an interval, and how do we know, how do we do it when we have to? Well, take the intervals that would normally add to an octave and diminish one of them if there's a strong interval among them. Otherwise, leave the intervals alone. There, done. There's nothing more to it. Here are all the interval sums that give an octave, sums of positive intervals, of course, that give an octave. That are, with intervals that are smaller than an octave. Note that they all follow our same interval adding rules as far as the number parts go. That is, you reduce the smallest interval by 1 and add what you get normally. We just have to, and of course, when we say sum, we just mean of 2 intervals because, you could add several intervals, In fact, if you add, I might make a video about that. If you add a set of intervals, you will get an octave with that, Okay, so we just have to diminish one of the intervals that add to the eighth, the octave, except in the case where both intervals are weak. So if you have a sum, and and one of the intervals is strong, you're never going to get 2 strong intervals to add to an octave. But if you have a sum and one of the intervals is strong, then you diminish one of them. If none of them are strong, if none of the intervals are strong, then you can then you leave it alone. You leave it alone, and that's actually a way in which a weak interval somewhat functions like a diminished interval. Note that there is only one case where both intervals are weak, a fourth and a fifth, and that no strong intervals sums yield an octave. Remember the strong intervals are the unison, the second, and the third, and the weak intervals are all the other ones up to a seventh. Fourth, fifth, sixth, and seventh. You can't add 2 of the strong ones to get an octave. But anyway, how do we recognize a multiple of an octave? How do we do that? You can easily recognize, anyway, you look at those examples, you could easily recognize the multiple of an octave because the number you see will always be 1 more than a multiple of 7. Not a multiple of a seventh, a multiple of 7. A multiple of a seventh is not forcibly a multiple of 7. This is actually true for other intervals. The length of a multiple of a seventh will always be 1 more than a multiple of 6. The length of a multiple of a fifth will always be 1 more than a multiple of 4, etc. But the one we need to worry about here is the octave. They're all easy to recognize, and you can look at the examples. Okay, and remember, you could always pause it and stuff. Now, armed with this information, it's easy to calculate sums of intervals involving octaves, and subtractions as long as the interval being subtracted is no more than an octave in length. What is an eighth minus a second? An octave minus a second? Well, remember that an eighth is a diminished second plus a seventh. There is always a diminished interval, except when adding a fifth to a fourth, weak intervals, which are weak intervals to get an octave. Therefore, an eighth is a second plus a diminished seventh. If we want to calculate the difference between a 22nd and a fourth, just remember that 22 is equal to 21 plus 1. And remember, 21 is a multiple of 7, which means that 22nd is a multiple of an octave. All we need to do is rewrite the sum so that we isolate an eighth. And we use that, we use what we know to calculate the difference between an octave and a fourth. And then add what we get to the octave. We know a fifth and a fourth add to an eighth, so an eighth minus a fourth is a fifth. We add the 15th to a fifth, we get a 19th, and no need to modify because we added to an octave. Remember what we learned from the properties video, that when adding an interval any interval to a multiple of an octave, you don't have to modify the result of the sum. I mean, unless there's some, like if there's a diminished symbol already there. So 22nd plus 4th is 25th. No modification needed. And 50th plus diminished 7th is a diminished 56th. And as usual, thanks for watching. See you next time. Please like, subscribe, and share. You know, we will use what we know about sums no larger than a seventh and summing to an octave, which we just covered, to add any group of intervals to each other in the next video. When we, in cases where we care about chromaticism, we already did this when we don't care about chromaticism, and it's not very accurate. But anyway, see you next time.